Hello there. My name is Andy Peoples, and I'm the Business Development Director for Quortus in Japan and Asia Pacific. And today we have a short-ish video presentation as part of the Kyoto Smart City Expo 2021. And first, I'd like to thank the hosts for inviting us to participate. And also a word of thanks to the people at the British Embassy in Tokyo, and particularly Arai-san from the Department of Industry and Trade for helping us to participate in this event. So I have as I said, a short-ish presentation and video today. Should be around 25 or 30 minutes stolen from your lives. And I'm going to talk a little bit about Quortus and our ecosystem partners in the area of smart cities, or cognitive cities as they're sometimes called. The running order here, the slides will be in both English and in Japanese. Where possible, both languages appear on a single slide, and where that's not possible because there is a lot of information, then alternately, English and Japanese will appear. In general, I'm going to start and talk about where smart cities have come from, the area of connected cities, where they are right now and where we're probably headed with the advent of private and local networks. To talk about the elements which we feel are important in the networking of a smart city, which brings in the role of Quortus and some of our partners, and then to talk about a use case which we have deployed commercially in a smart city type application in the United States. For the latter part of the slides, I want to talk a little bit about Quortus, who we are and what we do, and also some of the solutions from our key technology partners. And finally, a little bit about the important role of system integrators and service providers or OEMs in this market as channel partners. At the end of the slides, there are some contact details for myself, and of course, it would be most welcome to have any and all feedback, or if people want further information about anything that they have seen or heard or read in this. Okay, so smart cities have evolved from connected cities, and when we talk about connected, I think we're all familiar with traffic lights or street cameras, and for a number of years those have been connected physically by cables and wires under the ground or above the ground through to operations centers, and those operations centers allow the management and control of those systems. Obviously, there was quite an evolution with the advent of carrier networks and mobile networks, which meant that a lot of that infrastructure of cabling and wiring was not required anymore, and that data could be taken up from the traffic lights or cameras or the sensors to the data center and vice versa over the air. The stage of evolution that we're looking now is a move from a smart city to cognitive city, and that includes the whole area of artificial intelligence and future proofing. Really, we think that a vital step is that these would become private or local networks. So rather than networks provided by an external carrier, that the networks would be run and managed by the cities themselves, or run and managed on behalf of the city by a service provider or a system integrator. Of course, the broad use of the term city here, we mean any urban area or a subset of an urban area, so a city office or a town hall or a hospital or a university or something like that. Of course, there are a lot of key benefits to be had from moving from the public carrier networks to private networks and equal amount of challenges as well, it's fair to say. Some of the issues that the public carriers have covered over the years in terms of coverage and quality of service, again, need to be addressed so that for all of the connected devices, be those sending small amounts of data, such as meters or sensors, or those that are carrying large amounts of data, such as cameras or connecting automated vehicles, then the quality of the service and the ability to cover every part of the city is hugely important. Other aspects that are important in this move towards a private or local sphere are the areas of security, control, cost, and latency. And the control is important because it means that the cities can decide what types of services they provide, what sorts of applications are running, what kinds of software, what kinds of security, what sorts of policies. And of course, the secure element is hugely important if you want to make sure that your data is protected, it's not going out of your location, and malware or bad actors are having a harder time to access your user base. Cost, of course, goes without saying, is something that's a high priority for the optimization that comes with moving to private networks. And latency, again, the instantaneous real-time responses that are required for solutions such as automated vehicles. Now, it's a trend that's been happening for hundreds, if not thousands of years, the urbanization of global society. And it's projected that 3 out of 4 of us will live in a city or urban environment within the next 30 years, so by around 2050. And that in Asia alone, there will be several hundred new cities starting from scratch. So this again presents lots of challenges and a huge amount of opportunities for cognitive cities. So moving along to the next page, what are the key elements of a smart city network as seen from the network point of view? And we've tried to simplify this into the clouds that you see here, blue and red, and 4 layers of the network. So looking from the bottom layer number 1 up through to layer number 4, the bottom layer contains all of the actual devices, such as your handsets or sensors or cameras or end-to-end devices or meters or smart signage, automated vehicles, anything else. And in there, we have some of our solution partners, which we'll talk about later, that have applications running on these devices and taking the data up from them. This, of course, has to be on the actual site in the actual physical city. And then also in that physical location are the transport layers. So the LoRa networks, the Sigfox networks, or Bluetooth, 3G, 4G, 5G, public or private networks, or Wi-Fi. So all of the ways that these are carried forward and transfers the information needs to be there as well for access points and base stations. And it's, of course, not going to be a case of it's one or the other. It's Wi-Fi or 5G or LoRa or Bluetooth or anything like that. It's more likely going to be a case that some combination of all of these technologies will be required depending on the needs and the use case, the amounts of data, the timing, the costs, and all of that. So then looking through to layers 3 and 4, these are the data centers where the data is taken up, and then it's exported to dashboards for various different applications to use in order to provide security functions and monitoring and everything else. And again, you'll see within these pictures the Quortus logo. So the Quortus core technology sits in one of those data centers potentially, and so do some of our partners as well. And we'll touch upon those a little bit later. The Japanese version of the slides is here, for those who want to look at it. Okay. Next, we want to look at a smart city type case that Quortus has worked on, and this is in the United States. This is for the Utah Education and Telehealth Network. So they run around 25 campuses of a university educational system, and they're spread out over quite a wide geographic area. And what they required was to have a local network with all of the handsets and devices and sensors and everything else local to each educational institution, and the access points as well, of course, to allow the staff, be those teachers, educators or security, and the students to be able to interact with one another and have that data broken out locally. This, of course, is where Quortus is a building block, providing a core in order to do this. And the system integrator, which in this case is a company called TLC, provides this service to UETN. We're going to talk now a little bit about Quortus and who we are, where we've come from, and a little bit about the solution, the software solution which we provide. So Quortus was started in 2009 in the UK, close to London. We've been involved in other geographies since that, particularly in the United States and Western Europe, and in Japan since 2016. And the business model of Quortus is very much a channel partner one. We provide a software solution, a software core, which I'll talk about a little bit on the next slides, which is provided to a system integrator or OEM or a service provider who then works to provide that to the end user. So there's not a direct relationship between the likes of Quortus and the operator of a smart city. We work across a broad range of technologies. In Japan, that's from the 4G phase onwards, which covers the likes of SXGP, unlicensed technology, and local BWA, which is a local 4G. And then also laterally, we've been looking and working in the area of local 5G, and down the line that will be private 5G as well. The Quortus EPC, or Evolved Packet Core, is a software solution which we provide, and it can sit on a kind of hardware in a rack, an x86 type box, or it can be installed onto a smaller compute unit such as a Raspberry Pi or an Intel NUC. And it has all of the elements that you would expect to have in a large mobile network, but scaled down in order to support smaller size and scale out from small to big, essentially, allowing phone calls to be made, allowing SMS messages, and allowing all of the functions of a mobile core. We have that here in Japanese as well. Of course, this can be virtualized, provided by a cloud, or it can be an on-premise offering, so embedded into a device on a site for a small office, or for those types of end users such as hospitals or local governments that require an on-premise solution. Actually, I'm going to talk a little bit about a couple of our key partners that we have here. The first one is a company called JI Technology, which is a software solutions integrator. It builds its own software and then also integrates the software solutions of others. Been operating in the mobile space for over a decade, and for the last 4 or 5 years in the private network space, which plays into networks for enterprise, including smart city, working through creating of gateways and fintech-based payment solutions. And here, this is in Japanese as well. Again, a lot of gateways around IoT, SMS gateways, and working through SXGP, so the unlicensed 4G and Edge products. Two key solutions that JI Technology provide. Number one is access control. So this is essentially a security function, and people are familiar with malware protection and firewalls and that kind of thing. And this is really, if you think of security in terms of an old medieval fortress with barriers of security from the outside to the inside, then this is something of a very outer layer of security. It's really about, after you have created your nice network to work in a smart city with handsets and sensors and devices, then you want to ensure that those devices are authenticated to come on and work on that network, and that they don't do one of two things. They don't bring in malware and infect your network, or number two, take out information that you have within that network and expose that to parties who should not be aware of it. So this is really about checking that the SIM and the ID of the typically phone or any other device that has a SIM card embedded into it are appropriate and authorized to be on that network, and then to allow the management of that network to assess that these devices should be here, or if they find something that should not be there, to remove that from the network. The second interesting piece of technology from JIT is something called high availability. And in essence, this is about redundancy and backup. So from your own personal experience, people are mostly familiar with you have a laptop or a desktop, and you back up all of your data to an external disk drive in case your data is compromised or there's a hardware fault or a software fault, which means you cannot access the data on your computer. Therefore, you restore it from your backup, or in the extreme case, you buy a new laptop and you reinstall all of the saved data from your external disk. This is essentially forming a similar type of a role, except in a private network or a network for a smart city, where the core EPC is there. It allows the setup of a redundant system, that there are two pieces of hardware with two sets of software, and active and a standby. And if there is a localized failure or fault, this software allows the backup to come into play when the primary has gone down. And of course, this is something that exists in the large mobile networks for a long time, and has typically been associated with emergency uses, or something like a hospital where, if a network goes down, it must come back up straight away. It's situations where 24/7 usage of technology is essential. Then, of course, backups are required. However, it's worth bearing in mind that if you create a network for a city or for a business or for a university or any other case, and even if you're only operating on a Monday to Friday 9 to 5, and you have a failure on, for example, Wednesday afternoon, that means you're not able to work, make calls, send messages until Thursday morning, then that has a negative impact on your livelihood and on your business. So I think we're going to see going forward that this type of solution, correctly delivered, should also be applicable to everyday, ordinary, run-of-the-mill use cases, rather than those extreme use cases where it's 24/7 emergency use. On the slides close to the start, we had some of these logos from other solution partners that we have. I'm going to touch briefly on them here and tell you a little bit about what they do. If anybody wants further information, I'm happy to get in touch about that. From the top down, Waya is a software platform that allows a variety of different sensor technologies to work with one another. So if you have door and window and temperature sensors, for example, from different manufacturers, then they can all be plugged into this platform sucks up the data, which then can be used to understand room usage, for example, or temperature controls, or anything else that you want to look at. Something that's going to be increasingly important in urban environments going forward. And obviously, the COVID pandemic has brought into the foreground. Quortus, the second company here, is involved in the security space in terms of malware and phishing and smishing. And when we spoke earlier about having an outer layer of security to check that devices are authenticated in order to join the network, this is really looking after that. So the devices are there, handsets, tablets, etc. And it's about ensuring a couple of things. Number one, that they're not infected with malware, either intentionally, where the user going to a site and infecting it or pulling down some malware, or unintentionally because the device is going through a lot of places and becoming infected. The other thing that this software allows to happen is controls on policies. So if you want to ensure that certain sites are not looked at during the daytime, if you want to, for example, no YouTube 9 to 5, for example, or other policies you want to set in place, this can be done seamlessly and controlled and modified on a per device or per company basis. The third one here is a company called Endeavor. And again, this works in our ecosystem from the point of view that it talks about quality of service and coverage. So are you covering all of the areas that you need to cover indoor and outdoor so that you can make calls and send and receive messages, and that the quality is appropriate as well? And this is app on device, it's operating in the background on all of those devices that are deployed, and then has a server and a data center where, again, it can be accessed through a graphical user interface to manage and control and observe the data. 10T Tech here is eSIM, and I think a lot of people will be familiar with that these days. The standard SIM that you have in your phone is a piece of hardware. It's manufactured by large manufacturers and put into phones and other devices. And that's great as it goes, but from private networks going forward, I think we will see a necessity to have cheaper alternatives to that, and alternatives that are easier to manage. And if you have a software SIM that can be downloaded, then it can also be used for shorter periods of time. So to check into a hotel, or to use it for a visit to a certain enterprise, or to go into a certain city or town and avail of the facilities for a certain period of time. This can be done easily in software, and again, then the IMSI details used again in the future. The management is much, much more straightforward than if you have to physically create a SIM and then make sure that that is retrieved back and used again. Last one on this page is a company called Jaxx, and it very simply provides a smart USB which can be plugged into a laptop or a tablet or another device to allow it to be connected to a network. So the example that we have is where it's used in the SXGP network. If you have a town hall, for example, and each of the employees of the town hall has a laptop, this USB plugged into the side of it would connect all of the people in the town hall to the unlicensed 4G network, which can be, of course, used for both everyday business, or also in the case of a backup if there is a disaster of some kind which affects the public network, then this could be a secondary network. On this page, we have a couple of other technology partners. One too many to continue our disaster and emergency theme is about messaging to alert in the advent of disasters. So I think people in this country will certainly be familiar with the earthquake warning that you receive on your handset to say that there is an earthquake about to happen or a tsunami on the way. This allows that system to be set up for a city network or a private network. Airspan is a software vendor of fixed wireless network installations, so it creates access points that can be used indoor and outdoor for private networks. Acceleran and Benitel are both in a similar space, and it's about open RAN, so really about the software democratization of radio networks. Now, this slide is very important in that, as I've said all along, the software approach that Quortus has means that we are a building block, and indeed most of the other technology partners that I spoke about also provide building blocks for a smart city or private enterprise. It is the role in many countries, and particularly in Japan, of the system integrator or service provider or OEM as a channel partner to take that solution to the city or the private enterprise. And here in Japan, we have a couple of large partners such as Fujitsu and SoftBank, BBB, Hankyu, Hanshin, and a variety of others that work in very specialist areas. And these guys have the important task of pulling together all of the software type solutions that we have discussed, including the Quortus one, as well as any of the hardware that might be needed, whether those are sensors or IoT devices or handsets or access points, and taking those to a smart city, installing them, running them, maintaining them, and supporting them, or providing them to the end user of the city, in this case, for those guys to use. So it's a really, really important function. So that's the presentation for today. Again, thank you for your time. I'd be very happy to receive any feedback. And if anyone has any inquiries about our role in smart cities, about Quortus or any of our partners, then I'll be very happy to get an email in English or in Japanese to this address. And that's it. Thank you, and stay safe.